Hello everybody, here comes another iteration of me explaining the topic of Monopoly. My previous video lesson was 17 minutes long, so I'll try to make it even shorter this time and hopefully even more meaningful. So we're going to talk about Monopoly, a company that controls an entire market. Something quite different from perfect competition that we discussed earlier. So a company that controls the entire market definitely is not a price taker. So it is dealing with the entire demand curve for the whole market. And it can set prices depending, of what it likes. So today we're going to see how such a company is going to set its output and also the price. So you might think that it would like to set its price as high as possible. Well, that's not true, because that's the highest price, but it's not really good at all, because it's like a cutoff price. If you think about total revenue generated at this price, it's pretty much zero. By the way, this diagram shows us how much total revenue will be generated at any given price, at any given quantity. And the midpoint has special meaning here because it gives us the largest possible total revenue. So this line, this curve, is our total revenue curve, and it's very important, and we're going to use it later today. And actually, one important thing about this curve is that we can figure out marginal revenue by looking at this curve. So by definition, as I hope you recall, marginal revenue tells us by how much total revenue will change as we're changing our output. So in the simplest case, by how much total revenue will increase when we add one extra unit to our output. And the graphical interpretation of this variable is the slope of our total revenue curve. And this way we can understand the shape of marginal revenue. So to do that, we need to take a closer look at our total revenue curve. And as you can see, it's a bell-shaped curve, and it's growing and then reaching its maximum and then dropping. But we need to focus on its slope. And so what do we see about its slope? First, it's pretty steep, and it remains steep for a while, but this slope is getting flatter and flatter and flatter until it becomes like horizontal. And then it keeps going, now with negative slope. So if we just trace the slope, we'll understand the shape of our marginal revenue curve. So the one very important point here is this one, right? Because this is where the slope is zero. So we know that our marginal revenue curve is going to intersect our quantity line, horizontal axis, exactly at this point. Because again, this is where the slope of total revenue curve becomes totally flat, which means zero. And simply put, what we're going to get here, we're going to get a line that will go from here to here. And it will go further down, but we don't really care about this lower half. We mostly care about this section. Why we only care about this section? Well, because if you're controlling the market, right, you don't want to push your output and sales as far that your total revenue will start dropping just because you're trying to sell too much and lowering your price again too much. So we're just going to focus on this level of this kind of range of output. If the company's goal was to maximize total revenue, the answer would be quite straightforward. This is where we want to set our output, because that will give us the largest total revenue. But our goal is more complicated than that. It's more sophisticated. Remember, our goal is to figure out how to set the output so that profit, calculated as P minus ATC times Q, gets the largest. Well, another way actually to calculate profit is subtracting total cost from total revenue. So profit can be calculated using either formula. All right, so Next thing we're going to do is, in fact, to look at those two variables. In fact, we're going to look both at total revenue against total cost and see how we should set Q so that the profit gets as large as possible. And we're also going to use this formula and look at a diagram where we have ATC, price, and Q. But we also need other curves like MC and MR to figure out where this Q max is. And this discussion is very similar to what we did when we talked about perfect competition, but of course it's not exactly the same. So let's take a look at this bunch of curves. This one is basically total revenue curve that we just drew, only it's kind of extended. So again, we only care about the left half of it, so that's why we're only seeing this section. Total cost curve is the familiar thing. We saw it before and it doesn't change. So Monopoly presumably is dealing with the same total cost curve, which has the same shape. So next thing, how will we find the largest quantity that will give us the largest possible profit? On this diagram, it's pretty straightforward. You just need to find the largest distance between these two curves, total revenue and total cost, making sure that you are limiting your search to this area. Because to the left of this point and to the right from this point, profit in fact is negative, right? Because total cost exceeds total revenue. So our profit is positive between these 2 points. And if you just eyeball it, you can probably realize that this is the largest distance. That would be like a primitive, simple approach, but we now should know better, right? That's why I drew those 2 tangent lines. Hopefully you recall that those tangent lines basically help us to find the largest profit by looking for the level of output where marginal revenue equals marginal cost. So this is exactly what's happening at this level of output, because these 2 tangent lines are parallel. If you would look here, you see they will be not parallel. If you go further right, also they will not be parallel. Only when they are parallel, you're getting the largest possible profit. So as simple as that. Maximum profit. Again, this tangent line is marginal revenue, or the slope of this tangent line is marginal revenue, and the slope of this line is marginal cost. So marginal cost, and again, when they're equal, it means you're maximizing your profit. That's why we call this Q max, reminding ourselves that we're talking about profit maximizing level of output. All right, so after we figured profit maximizing level of output on this diagram, now let's take a look at this one. So what's going on here? Here we have our demand curve, we have a marginal revenue curve, which again relates pretty much to the slope of this curve. So that should make perfect sense, especially after our discussion here. And then, of course, we have marginal cost, which we discussed earlier many times. And then we have ATC, which again looks exactly the same way as for a perfectly competitive company. And so on the lower diagram, we just need to kind of use the same logic we used earlier. Again, when talking about perfectly competitive company. So where is MR equals MC? Right here. So this intersection should match basically profit maximizing level of output, because, well, when you're maximizing your profit, that should be true. So therefore, this intersection should match this maximum profit on the upper diagram. And well, that's pretty much it. So marginal cost, marginal revenue. We know where marginal revenue comes from. Well, we should remember where marginal cost coming from. So the only thing left here is to figure out how much money the company will make looking at the lower diagram. because again, on the upper diagram, things are pretty straightforward. This is our profit. Here, it's not just a distance between these two curves. It's if you recall, it's an area, right? It's P minus ATC times Q. That's where we find it on the lower diagram. So let's do that. Where is our P? Well, at this Q, you find it by going up until you hit your demand curve. That's how much you can charge if you want to sell that many units. You cannot charge more because people will not buy it, and you don't want to charge less, because why should you charge less if you can charge, up to this price? So that's the price you're charging. And at this quantity, your ATC is this much, right? So distance between these two curves, P, which is our demand curve, and ATC, which is our average total cost curve, times Q, gives us the profit. So graphically, this is what our profit is. Well, maybe I better show it on this graph. So this distance is P minus ATC, and if we extend it to make a rectangle, we'll get this area for our largest possible profit. So this is price, this is ATC at this Q. Here we go. That's how you figure out profit maximizing level of output and profit itself on both diagrams. But of course, we mostly use this one to understand what's going on, and we're supposed to actually be able to work with this diagram without even looking at this graph. So be prepared to deal with these curves. All right, so next thing is to talk about efficiency or inefficiency of monopoly. And well, the thing is, monopoly will underproduce in comparison to the point of allocative efficiency. Because remember, the point of allocative efficiency is achieved where you making your marginal cost equal your marginal benefit. Speaking of which, our demand curve is telling us not just what the price is, but also what the marginal benefit is. So demand curve is telling us what marginal benefit is for society. Because when you're selling a unit of stuff to people, they're paying up to their marginal benefit from this unit. Therefore, again, demand tells us what marginal benefit is. And based on this logic, you want to produce all units for which MB exceeds MC. In other words, you want to produce up to this point. So as long as marginal benefit justifies marginal cost, we want to keep producing. And basically, when we're producing this last unit, this is where we're running out of units for which MB exceeds MC, and we should stop. And by doing so, we will also maximize our surplus, which will be this area. But monopoly will not go that far. It will produce less, because its goal is not to maximize overall surplus, total surplus. Its goal is to maximize profit. And we just figured out earlier, a minute ago, that its profit maximizing level of output is exactly where marginal cost meets marginal revenue, not where marginal cost meets the demand curve. Therefore, the monopoly will produce less, and that will result in deadweight loss. Deadweight loss from the lost total surplus, because monopoly will fail to produce these units, and therefore this total surplus will be lost, and therefore it will generate what we know as deadweight loss. All right, so here we are. I did it, and it's actually, I stayed under 15 minutes. I hope you guys enjoyed it. Thank you for your time.